Charon is the largest satellite of the dwarf planet Pluto. It was discovered in 1978 at the United States Naval Observatory Flagstaff station. Following the 2005 discovery of two other natural satellites of Pluto, and two more in 2011 and 2012, Charon may also be referred to as Pluto I. The New Horizons mission is scheduled to visit Charon and Pluto in July 2015. Discovery. Charon was discovered by United States Naval Observatory astronomer James Christie, using the 1.55-meter telescope at NOFS, and was formally announced to the world via the International Astronomical Union on July 7, 1978. On June 22, 1978, he had been examining highly magnified images of Pluto on photographic plates taken at the 1.55-meter Flagstaff telescope 2 months prior. Christie noticed that a slight elongation appeared periodically. Later, the bulge was confirmed on plates dating back to April 29, 1965. Subsequent observations of Pluto determined that the bulge was due to a smaller accompanying body. The periodicity of the bulge corresponded to Pluto's rotation period, which was previously known from Pluto's light curve. This indicated a synchronous orbit, which strongly suggested that the bulge effect was real and not spurious. All doubts were erased when Pluto and Charon entered a 5-year period of mutual eclipses and transits between 1985 and 1990. This occurs when the Pluto-Charon orbital plane is edge on as seen from Earth, which only happens at 2 intervals in Pluto's 248-year orbital period. It was fortuitous that one of these intervals happened to occur so soon after Charon's discovery. Observations. Images showing Pluto and Charon resolved into separate disks were taken for the first time by the Hubble Space Telescope in the 1990s. Later, the development of adaptive optics made it possible to resolve Pluto and Charon into separate disks using ground-based telescopes. Physical characteristics: Charon's diameter is about 1,207 kilometers, just over half that of Pluto, with a surface area of 4,580,000 square kilometers. Unlike Pluto, which is covered with nitrogen and methane ices, the Charonian surface appears to be dominated by less volatile water ice, and also appears to have no atmosphere. In 2007, observations by the Gemini Observatory of patches of ammonia hydrates and water crystals on the surface of Charon suggested the presence of active cryogeysers. Mutual eclipses of Pluto and Charon in the 1980s allowed astronomers to take spectra of Pluto and then the combined spectrum of the pair. By subtracting Pluto's spectrum from the total, astronomers were able to spectroscopically determine the surface composition of Charon. Charon's volume and mass allow calculation of its density, from which it can be determined that Charon is largely an icy body and contains less rock by proportion than its partner Pluto. This supports the idea that Charon was created by a giant impact into Pluto's icy mantle. There are two conflicting theories about Charon's internal structure. Some scientists believe it to be a differentiated body like Pluto with a rocky core and an icy mantle, whereas others believe Charon to be of uniform composition throughout. Evidence in support of the former position was found in 2007, when observations by the Gemini Observatory of patches of ammonia hydrates and water crystals on the surface of Charon suggested the presence of active cryogeysers. The fact that the ice was still in crystalline form suggested it had been recently deposited, because solar radiation would have degraded older ice to an amorphous state after roughly 30,000 years. Photometric mapping of Charon's surface shows a latitudinal trend in albedo, with a bright equator band and darker poles. In particular, the south polar region seems darker than the north. Orbital characteristics: Charon and Pluto revolve about each other every 6.387 days. The two objects are both gravitationally locked to the other, so each keeps the same face towards the other. This is a mutual case of tidal locking compared to, for instance, Earth and the Moon, where the Moon always shows the same face to Earth, but not vice versa. The average distance between Charon and Pluto is 19,570 kilometers. The discovery of Charon allowed astronomers to accurately calculate the mass of the Plutonian system, and mutual occultations revealed their sizes. However, neither indicated the two bodies' individual masses, which could only be estimated, until the discovery of Pluto's outer moons in late 2005. Details in the orbits of the outer moons reveal that Charon has approximately 11.65% of the mass of Pluto. This shows it to have a density of 1.65 Aa plus or minus a 0.06 grams per centimeter 3, suggesting a composition of 55 Aa plus or minus a 5% rock to 45% ice, whereas Pluto is somewhat denser and about 70% rock. Simulation work published in 2005 by Robin Canup suggested that Charon could have been formed by a giant impact around 4.5 billion years ago, much like Earth and the Moon. In this model, a large Kuiper belt object struck Pluto at high velocity, destroying itself and blasting off much of Pluto's outer mantle, and Charon coalesced from the debris. However, such an impact should result in an icier Charon and rockier Pluto than scientists have found. It is now thought that Pluto and Charon may have been two bodies that collided before going into orbit about each other. The collision would have been violent enough to boil off volatile ices like methane but not violent enough to have destroyed either body. Classification as a moon or dwarf planet. The center of mass of the Pluto-Charon system lies outside either body. Because neither object truly orbits the other, and Charon has 11.6% the mass of Pluto, it has been argued that Charon should be considered to be part of a binary system. The International Astronomical Union states that Charon is considered to be just a satellite of Pluto, but the idea that Charon might be classified a dwarf planet in its own right may be considered at a later date. In a draft proposal for the 2006 redefinition of the term, the IAU proposed that a planet be defined as a body that orbits the Sun that is large enough for gravitational forces to render the object spherical. Under this proposal, Charon would have been classified as a planet, because the draft explicitly defined a planetary satellite as one in which the barycenter lies within the major body. In the final definition, Pluto was reclassified as a dwarf planet, but the formal definition of a planetary satellite was not decided upon. Charon is not in the list of dwarf planets currently recognized by the IAU. Had the draft proposal been accepted, even the Moon would have been classified as a planet in billions of years when the tidal acceleration that is gradually moving the Moon away from Earth takes it far enough away that the center of mass of the system no longer lies within Earth. The other moons of Pluto, Nix, Hydra, Kerberos and Styx, orbit the same barycenter, but they are not large enough to be spherical, and they are simply considered to be satellites of Pluto. Name: Charon was originally known by the temporary designation S/1978 P1, according to the then recently instituted convention. On June 24, 1978, Christie first suggested the name Charon as a scientific-sounding version of his wife Charlene's nickname, Char. Although colleagues at the Naval Observatory proposed Persephone, Christie stuck with Charon after discovering it coincidentally refers to a Greek mythological figure. Charon is the ferryman of the dead, closely associated in myth with the god Hades, whom the Romans identified with their god Pluto. Official adoption of the name by the IAU waited until late 1985 and was announced on January 3, 1986. There is minor debate over the preferred pronunciation of the name. The practice of following the classical pronunciation established for the mythological ferryman Charon is used by major English-language dictionaries such as the Merriam-Webster and Oxford English Dictionary. These indicate only one pronunciation of Charon, when referring specifically to Pluto's moon, with an initial K sound. Speakers of many languages other than English, and many English-speaking astronomers as well, follow this pronunciation. However, Christie himself pronounced the ch in the moon's name as sh, after his wife Charlene. Because of this, as an acknowledgement of Christie and sometimes as an in-joke or shibboleth, the initial sh pronunciation is common among astronomers when speaking English, and this is the prescribed pronunciation at NASA and of the New Horizons Pluto mission team. In popular culture, the Mass Effect video game franchise is built around the premise of a series of relays that allow faster-than-light travel around the Milky Way without time dilation. In the series, Charon is discovered in 2149 not to be a moon or a dwarf planet, but to be a chunk of ice containing an intricate piece of technology built by an ancient civilization that allows this travel to occur, leading to the discovery of other planetary systems and enabling their colonization. In the 1974 sci-fi novel The Forever War written by Joe Hordman, a group of elite military recruits train for combat on a fictional icy planetoid called Charon that orbits the Sun at a distance of 80 AU. Being that the story was published 4 years before the discovery of Pluto, a Euro-unregistered trademark S largest moon, it is unclear whether the fictional Charon of the story somehow factored into the naming of Pluto, a Euro-unregistered trademark S moon, or if the two share a name purely by coincidence. The Jonathan Coulton song I'm Your Moon from the Thing a Week 4 album is a love song sung to Pluto by Charon. See also, Moons of Pluto, Notes. References. External links, Charon profile at NASA's Solar System Exploration Site, James W. Christie and Robert S. Harrington, The Satellite of Pluto, The Astronomical Journal 83-1005, Mark W. Buie, Phases of Charon as Seen from Pluto, Lowell Observatory, Buie, Surface of Charon in Pluto, Hubble reveals new map of Pluto, BBC News, September 12, 2005, IAU Circular number 3241 describing the discovery, measuring the size of a small, frost world, MJ Personnel Charon, a Euro-unregistered trademark S radius and density from the combined data sets of the July 11, 2005 occultation, cryovolcanism on Charon and other Kuiper belt objects. New Horizons camera spots Pluto, a Euro-unregistered trademark S largest moon, July 10, 2013.